And second day, but third class. Huh? We are going pretty fast. Uh, so this is the lecture. So research methodology, the first part, module 8, huh? Among RMRP, research methodology, research and publication ethics. We are into the module 8. This is the last class for research methodology. Huh? Then the rest is statistics. Huh? That will be taken by madam later on. Huh? So right now, come and sit. There is no space. I have not brought the attendance sheet, right? Okay. So what we did yesterday, we'll just have a recap, huh? So that we do because we don't want that you go home and then again with the base subjects you struggle with this also. So we just repeat what we did yesterday. So this is what, huh? First we did what is motivation and what is research, objective for research, and then we try to understand the Pasteur's quadrant, huh? Quadrant model. So here what we understood is that along the y-axis we are plotting the quest for fundamental understanding, and along the x-axis the use, application. So one which has both objectives, which has a fundamental understanding as well as use, is an applied research. So most of us are doing this, and that is really has a lot of applications direct in the society. And then there are pure applied research where there is no fundamental understanding, and there are pure basic research as well. Well, no quadrant doesn't fit into anything that we studied last year. So, and then we went to what is research methods and what is methodology. Well, everybody is clear, right? So methods are the techniques which we use during the research methodology. During your research, whatever techniques you will use, those comes under research methods, which is different from research methodology. So we just listed, we studied what is that research methods, that is can be put into three groups. Three groups. Research method comes under, first is concerned with the collection of data. So whatever data we are collecting, we are using some equipments or something else. So whatever data we are collecting, the data collection in a lot of classes. So generally this is a broad. So by questionnaires and all those, that we will do later on. The second group consists of statistical techniques, which again you will do in the next classes. After this, again the classes will stop. Now we'll go into RP, publication ethics classes. And then again madam will come later on and then continue with the statistics. So that is a research methods method. And the third group consists of those methods which are used to evaluate the accuracy of results. Though that will also be included there in the research methods classes. While methodology is a systematic way to solve the research problem. Okay, in it, the various steps that are generally adopted by researchers in studying his research problem along with the logic behind them. And foremost, these are the methods, research methods, means calculate mean, mode, median, standard deviation, how to apply particular research techniques. But research methodology includes these research methods, as well as you also need to know which of these methods are relevant and which are not, and what would they mean and indicate and why. This is what is methodology all about. From today, we will go into, and then we understood what do we mean by in the second class, fundamental versus applied research, descriptive versus analytical, quantitative versus qualitative, and conceptual versus empirical. So this is what we did yesterday. In short, I am giving so that you before your exam, so you can just recap. This yesterday's PPT was shared, right? No, nation. I have not shared the PPT with them today. Today they will share. So okay. So how they will get? Okay, I don't know. You have common mails, chemistry, All the three mails are there. So you have my email ID, na? If you send me that common, I can send you. I can directly send you if you want, Then there is no need if you want. Otherwise, if you want the madam to coordinate, you can contact madam. I can send her, and then you can go ahead. Whatever way, is convenient to you. If you want it right now, then after today's class, you just send me you drop an email with the list. Everybody has that. Just from the two email, whatever you get, copy everybody's email and send it to me. I will send you all the 3 lectures. And every day before coming to class, I'll send so that you have a prior idea. So we go into research process. This is research methodology introduction classes. So here we'll just understand the terms. Again, we will repeat those during my next classes. From tomorrow onwards, we'll repeat those, but each of them will be studied in details. So today is just introduction. What are the terms used in research process? Okay. In general, so when I came, this chemistry TA means JRF, I presentation 8 minutes they gave me. Okay? So very short. So during that 8 minutes, I just told them in terms, so everybody's telling you what is the research objective, work plan. But here in research methodology, the terms are different, similar, but only the terms are different. So you need to know the terms. That is UG system. You should know it, right? So this is what research methods in a flow chart. How we will go about during these 5 years. Not 5 years. Somebody should complete in 3 years as well. That is the fastest. So, first step is to define the research problem. First step. Okay, this is a research process. No need to write. You will get all these things. So first, as you go and join the lab, wherever you are joining, you have the rule is that you should define the research problem, but your guide has already decided it for you. So your one job is cut off. But this is an important aspect. Don't just to try to understand. If you do research on a problem which is not yet completely understood, or there are gap areas in this, so you will I will come when I teach you in details in the next classes. So if you do a proper research problem definition of whatever you will do, you will gain at the end. That you will understand after 5 years. Or sorry, I should not have 5 years. Somebody can complete in 3. After end of your research, PhD. Research is not ending. Research is whole life you are doing. And then how we will come to know about the problem? By a proper review of literature. So whatever topic you are interested in, you should do a proper literature review. So literature review, there is one classes, but I take 2 classes. One is how to get a literature review. What you are studying means whatever, how should you get a proper review of the literature done, what you will use. But in addition to that, you can also write a review, right? You have heard of review articles, right? So you have studied also, means. So you can also think of writing a review article at the beginning. Okay, this is the field probably I am going to work in, and you can start writing your own review. So that will help a lot. So that also we will take one class for that. And then after a proper literature review, formulate a research hypothesis. Hypothesis is nothing which is not yet proven. Okay, you propose it. So during your thesis, the first stages will be definition of the research problem, and then you propose a hypothesis. So that hypothesis, you will work on it. How you will whole work to prove that hypothesis throughout. And how you will work on it is doing a research design. So this is the most important stage of your research methodology, is that a proper research design. How to design, how we will go about one by one. Okay, what research methods you will adopt during your research design. So all this comes under research design. Here you include the sample design as well, how many samples you will take. So all that will come in details, the classes. And then you start execution, means come sit here, there are 2 seats available. So you have collection of data. The next step, so you start analyzing, means collecting the data with the help of equipments or instruments. चला गया क्या? Yes, हाँ, वो attendance sheet नहीं लाया, आप लेके आ सकते हो गेट पे? हाँ. So I've asked him to bring the attendance sheet because Madam told yesterday that she will keep it here. It's not there. It is in that place, na? You have any idea? No. Okay. So this is how we go about. We define the research problem. Then after defining, we review literature on the problem. You cannot deviate. You no need to deviate too much, and you do a proper literature survey. Then formulate your hypothesis. Make a proper research design. then you collect the data, then you analyze the data. Okay, and this analysis of data should be connected with your research design and the hypothesis. Okay, so you try to prove the hypothesis in that case, and then you interpret, report it in the form of publications, and finally in the form of thesis. Huh? So this is the research methodology. So what methods we follow during our research stages. So this chart indicates that the research consists of number of closely related activities. It's not that one is separate. It's not that initially you are starting a research on some problem. Suppose, again, we'll start. I brought some examples. We'll discuss it. The mixed bioscience, chemistry, physics, as well as engineering sciences people are there. So suppose you start a problem with material development for some application. Suppose I did my PhD in catalytic applications. Okay, so it's used as a catalyst for a particular reaction. And you start studying that with a proper, suppose I did a proper review of literature and I started studying, and then formulate a hypothesis, design, execution, analyze, and interpret and reported it. But suppose that catalyst can be used for some other reaction also during my journey, I understood, and then no harm in applying it to other, again do a research methodology for a different reaction which is related with that material, or another material of this for the same reaction. So it's not that once you go through the process it's over. You repeat and repeat it again and evolve yourself. You get more and more knowledge on that topic, and you evolve so that these steps are closely related. That is why they say. So if you have in-depth knowledge in your field, you will understand and then evolve in it. If subsequent procedures have not been taken into account in the early stages, serious difficulties may arise which may even prevent the completion of the study. So why I'm telling this? Because say generally nobody, one of you will not land up in this, but suppose somebody who is inexperienced, so he takes a material catalyst, he selects a catalyst without prior knowledge, without a proper literature review. It may not be active for the reaction. Why? Because in what we do is heterogeneous catalyst. Heterogeneous catalyst means there is a surface, okay, and there are active sites. So that catalyst might lack that active site. It may not be active for that reaction. This I'm talking about chemistry. If there are some seats, I don't know whether any seats left. No. Okay, one is there. So this is how. So he struggles. The student struggles continuously. He's trying to do the reaction, but it is not. It will not come out. It will not. Again, if suppose suppose we now enter into some specific problem. Suppose platinum-based catalysts are very active for reactions. Okay, and what suppose you do a high temperature reaction, so thermal, around say what I did during my PhD, 800, 900 degrees Celsius, we do the reaction. So at that temperature, if platinum tends to agglomerate, one and two platinum nanoparticles will come and adhere together. This is process known as, you know what it is? There are metallurgy people right here. Nobody? One only. So what is? So what it is called when two particles will thermally agglomerate together at high temperature? Agglomeration and aggregation is it, but there is a metallurgical term. This is not sintering, right? Have you heard? Have you studied? Isn't it? Sintering. So the particles tend to adhere together by the process of sintering, or they lose the porosity. Lose the porosity, it becomes denser. So you make density measurements, and so what happens in catalysis? How you prevent that? How we were preventing by use of a support. In catalysis, you use a support. Suppose silica SiO2 in chemistry is used as a support because silica is having a high surface area, so the platinum can be dispersed over the silica, like you are sitting separately, dur tak rahega, and but at high temperature, if there is no support, they will agglomerate. But with the help of a support, what will happen? See, suppose these are two platinum, they are having some support and platinum active sites, platinum and support interaction, PT SiO2 interaction is there. So this is preventing the PT-PT interaction. So this is how the whole logic is, how we prevent it, and with the use of supports. More the higher surface area of the supports, better is the dispersion. The platinum will be separated to larger degree. So, and then in addition to that, if the support is porous, you can have very high surface area, and there will be inside that where the platinum can go and sit and prevent agglomeration. And then there are more and more porous solids nowadays, which are evolving. Have you heard of them? There was very high porosity. There is a project in chemistry also, huh? MOF. See, she is knowing. So metal organic framework. So 1 gram of metal organic framework. So per gram, they are having meter square level of area. Some of them are having. Okay. So this is what. So such type of porous materials, if you take, you can disperse it. Now somebody is trying which is not at all porous. So he will not succeed, right? So initially you have to, the better the literature survey you do, the better type of research problem you can define, and the hypothesis and the proof will also be better. Sorry, madam, I just forgot. It's okay, no? Attendance sheet, no? Again, what they are telling, one should remember that the various steps involved in a research process are not mutually exclusive, nor are they separate and distinct. So, as I am telling, the research problem define kar diya, our problem ne, or literature survey nahi karna. No, not like that. We have to continuously evolve. Whatever problems we are facing, we have to solve continuously. So, it's not that it's separate and distinct. So, during the execution of data, also you have to go to literature and see whether it is coming. So, yesterday, it only happened in our lab. One student was collecting the Mott-Schottky plot. Mott-Schottky is a phenomena by which you can measure the semiconductor band structure, or the and you can tell what type of, it's an N-type semiconductor or P-type semiconductor with the help of an electrochemical technique. So he did with many samples, and he was struggling with a new sample. So then he went and saw the literature, how it have to be done and how it looks like, and he could correlate. Okay, it will be like this, and so on. So they do not necessarily follow each other in order, and the research and each step in the research process, the requirements of the subsequent steps. Okay, so this is what the research process is, and then we come to the last part of our this introduction class. That is research stages. So these stage, each of these stage, 1, 2, 3, 4, 5, 6 to 11 stages will take about 1 or 2 classes for each, or 2 stages in 1 class, like that. So like that we will continue from next class onwards. So these stages, what are these? So there are 11 stages. You have to remember all of these, means at least the names. What are the 11 stages? And we will just go through during this introduction, just introduce you to these stages. Details we will do from next class onwards. Okay. So first is formulating the research problem. So as I told you, regular research process, it's a different terminologies used. Stages is a very nice word, means how you will evolve during your research or the research career. Formulating the research problem, extensive literature survey. So right now I have spent around 20 years in this institution, but still I follow the same thing when I start a new research problem. I have to go and do a literature survey. I have to extensive literature. I have to define a hypothesis, okay, with the gap areas, and again follow the same order as you do. I am also done the same thing. Still, you have to do like that. So preparing the research design, then we have to design what I am going to, what are the research methods I am going to follow. Okay, and then determining the sample design. We'll do details in the next class. Sample design means, suppose, as I told you, that same example we are taking platinum on silica. Suppose we have PT, SiO2, catalyst you are designing, and then how many samples you will prepare. So platinum, why it is important? Platinum, because it is an active as a catalyst. It can accelerate the rate of reaction. What is the catalyst? You know, remember? Huh? Huh? It decreases the activation energy, right? By following an alternative pathway. Decreasing the activation energy by alternative pathway, and it decreases the activation energy. Now, suppose you have platinum. The higher platinum amount, the better will be the activity, right? Because more number of active sites. But again, platinum is costly. So you have to make a compromise, right? And you have to come to the proper amount or optimize the platinum content in your PT-SiO2 catalyst. This is one problem I'm telling you, optimizing the content of PT. There are other problems that we will slowly discuss. So this, say suppose now you have to prepare, you can prepare 0.1%, 0.2%, 0.3, like that, you can prepare 100 samples. But that is not feasible, right? Because it will take a lot of time. So somewhere, so that is why this determining the sample design is also very important. So how many samples will prepare? What are the ranges? So 1, 2, 3 will take 1, 2, 3 weight percent, or 0.1, 0.2, 0.3, or 1, 5, 10 weight percent. So that you have to, that also the sampling design also you have to make. How many samples will prepare? You cannot take, so it will take 5 years to just to evaluate the activities of those 100 samples. No, so that is not feasible. Collecting the data. So during data collection, what things we have to remember, those we'll discuss, okay? And then execution of the project, analysis of the data, hypothesis testing, generalization and interpretation, preparation of the report or presentation of results, that is formal write-up or conclusion is reached. So these are the research stages. For each individual publication also, you will follow all these stages. For the whole thesis also, this is meant to be followed. So this is presented to you so that initially you keep in mind and formulate your thesis like that. Okay, initially only. So just a brief thing. So formulating the research problem. So there are, how we will formulate the problem, those which relate to states of nature, those relate to relations between variables. So this is how, these are the two types. Single out problem for study, that is, researcher must decide the general area of interest or aspect of a subject matter that he would like to inquire into. So you have to single out the problem. Means it's known as, have you know the term, that funneling effect? Funneling, during class 10, when we were in class 10, so we have all options. As soon as you enter 11, science lilia, but that's arts and commerce option is gone. So you are limiting yourself, right? Then somebody in 12, after 12, took biosciences. So again, physics, chemistry, and all those engineering has gone. So slowly, as we grow up, we become like a funnel, and then you get choked up at because it's only one way where you can come out, right? Now a chemistry, yesterday some chemistry people came, kya karenge sir, what we will take. So right now you have very limited options, so you have to take with that. You cannot tell, okay, I will take biology problem and or organic chemistry. So we already have funneled out, right, like that. So during your research problem also, you will see that what I told as a catalyst, right? PT-SiO2. You can think of so many supports. Silica is a support, SiO2. Like that, you can think of TiO2 as support. You can think of zirconia. Well, so many low-cost materials which can be prepared in high surface area. This is a basic theory. I am concentrating on catalysis because I am from that field. Come. So like that, you can think so many things, so many samples we can think of, and so preparation can go on. But which one you will take? Again, for platinum, these platinum group metals they are called. So platinum, palladium, iridium, rhodium, all of them you can take. But which one? You have to select few during your problem. So you have to funnel out, or the subject cannot be kept broad, so broad. You have to figure out what you will inquire into or single out, they are telling. You cannot keep it very broad. Okay, initially the problem is starting in a broad general way. Initially, see all the problems, all the projects, I think bioscience have not got, physics, chemistry, whatever problems you have been given, they are much broader. It's not that you will, suppose our problem which we have given, that we will not do work on all catalysts for hydrogen energy, right? But initially it has to be broad. Slowly, what the ambiguities, if any, relating to problem will be resolved later. Slowly you will single out. You start with the one of the sample, and then related to that you concentrate, focus. It's not that initially only you will single out. Okay, a broader sense. So an optimum uh, area we will select. The feasibility of a particular solution has to be considered before working a formulation of the problem. So feasibility is very important. Huh? So in a laboratory where there is the equipment is not there, you cannot think of working the problem of that sort, or the skill set is not there. Suppose we are designed for catalyst, so somebody comes and tells, "Sir, hum optical properties karenge," so it will not be possible, because we are having the skill or the infrastructure only for doing those kind of things, right? This is what you have to remember during problem statement itself. So feasibility has to be seen from the perspective of the infrastructure available, as well as the feasibility as a whole. You cannot think of something absurd. We will do something with platinum bulk and then study the reaction. It will not be possible, because feasibility has to be thought out. The formulation of the general topic into a specific research problem thus constitutes the first step in a scientific inquiry. Okay, all those things we have to remember. Essentially, two steps are involved in formulating the research problems: understanding the problem thoroughly. How you will understand the problem, I'll tell you next, and rephrasing the same into meaningful terms from an analytical point of view. So two steps: understanding the problem. So whatever problem you are selecting, so somebody was asking chemistry console, so whatever you select out of those, whatever you have been given, select 5, and then study those 5, study those, what are the problems, what can be done, and whether it is meaningful, whatever the areas we can go. The best way of understanding a problem is to discuss it with one's own colleagues or those having expertise in the matter. So these are the steps. We'll study details in again. So the what way you can be helped in formulating the problem, how you can take help. So you can take help from the colleagues. So related area people, you can just inquire. Okay, and then suppose you are coming from some university, you can contact those people, and here there will be guides, co-guides, and then there are other people. With them you have to sit and discuss. Oh, okay, whether we will take up this problem, how we will go ahead. In an academic institution, the research can what it is, it can seek the help from a guide. So the guide is just going to help you, right, in this formulating the problem, because initial stage you are coming, you have to you are not having the complete area. So this is one of the method by which you can be helped. So seek the help from a guide who is usually an experienced man and has several research problems in mind. Often the guide puts forth the problem in general terms, and it is up to the researcher to narrow it down. Okay, so guide will give you in a broader way. They see you can do this, and this. All these 4 problems you can take up. So then you have to narrow it down. It's up to you. So I told you, you have to take the decision like that and phrase the problem in operational terms. In private business or in government organizations, the problem is usually earmarked by the administrative agencies, right? Administrative agencies means there are in government institution and private. Suppose some food manufacturing unit, you cannot, if you go and enter there in that industry, you cannot think of you will manufacture or do a research in LED, right? You have to be to the mandate of that organization, of that, if it's a private organization, according to what their motto is. And if it's a government institution like us, Department of Atomic Energy, so here the problems are marked by the administrative agency. There are the broad problem areas in which the problem in which you will work will be earmarked by the agency. So here you have the umbilical targets. You know about umbilical targets, and you have been, nobody has been told. So in 202 from 202 2047, 50 100 years of independence. So 75 years covered. So 75 to 100 years. This is known as the Amritkal. So you are entering the Amritkal. So you will do PhD and your initial career. So you will behave Amrit. You will be. So you are very important persons. So you will be doing research in this Amritkal, and all the government agencies like other research organizations like CSIR or even other agencies, they have their Amrit Kal targets. So till 2047, they have defined, okay, we will work in these areas. Whatever the problem have come to you are those in those areas. Like that, all the government organizations here, therefore having defined Amrit Kal targets. Okay, so this is what. So these are mandates of the organization, or right now for India, it's the Amrit Kal target. So by 2047, we are targeting self-reliance, right? Huh? So we are becoming independent. So I told you yesterday, I spoke about the energy problem, right? So in energy sector, in the fuel sector, we are dependent. Why we are dependent? We are importing fuel, right? Huh? Now US, they are telling, stop imports from Russian oil. We are importing because we do not have their own oil, so we have to import. But suppose tomorrow you have a solution where you can uh, fuel the cars or future cars with the help of hydrogen. Suppose, if we can see that day during this Amrit Kal period, then we will become self-reliant, we'll be independent. Then no need for oil itself. Why? What Russia or Southeast Asia? Why we are not concerned, right? So that is what. So why these problems are important? Because we will become self-reliant. India will attain Atmanirbhar, right? These are the terms. So I told you that how you will funnel out or figure out the feasibility and all those things is only by literature survey. Right now we have not done work. So what we'll go? We will go to the literature and do a survey. What has been done in this field till now? A proper literature survey that you have to do. And whatever you are selecting, I would suggest you start it already. See, if you have already selected some problem, whatever problem you are selecting, each one of you start doing a literature survey in that area. So by that you will gain knowledge in that field. So during literature survey, whatever for the researcher worker enrolled for a PhD degree, it is often required to write or present a synopsis proposal of the topic and submit it to the necessary committee or research board for approval. So this is a protocol generally followed initially. The broad area we select, and there is a committee in HBN also. There is a committee. For sciences, I think they are board of chemical sciences, board of physical sciences, like that it is called. And there are that committee, in front of that committee generally a presentation is made. I don't know about you, whoever employee. So I did PhD from HBNI. So initially I have to go and present it, what I want to do. And the committee, because the committee is experienced people are sitting, so they can take a good judgment whether whatever I am proposing is feasible, important, according to the mandate, or not. So accordingly, they will suggest me modifications or changes in that project, right? And then if it is approved, it is approved. If it is not fulfilling any of the criteria, not feasible, infrastructure is not, or not according to the mandate, then they will suggest change karo, and then we will resubmit, and then it will be again presented and approved. So this is what a general rule is. But again, here we have already, I think, I don't know whether you will be followed or this not. But for this, you need to do a literature survey because we have not done the work, right? At this juncture, the researcher should undertake extensive literature survey connected with the problem. For this purpose, the abstracting, indexing journals, and published or unpublished bibliographies are the first place to go on. Okay, so references. You have heard of references. Everybody has done projects and done something, some work or not. If somebody has not done also, there are reference. You in a research paper, you cite references. And in a review article, the number of references are huge because they give a gist of what has been done till now of those references. Say minimum 100 is the criteria for a review article. You see the top journals like chemical reviews and those, they give references up to 300 to 500 journals, papers. So like that, so those references are known as bibliographies in research methodology. Okay, even if you go and see the HBNI website, and if you see the thesis format, they will mention bibliography. So this is a term used. So those bibliographies are nothing but references. Academic journal, conference quoting, reports, books, etc. must be tapped. Okay, and these are the general guidelines there. The earlier studies, if any, which are similar to the study in hand, should be carefully studied. A good library will be a researcher at this stage. So what you are creating is a good library for yourself, for your work, right? So this is what in literature survey. Then after literature survey, what you do is generally development of working hypothesis. After extensive literature survey, researcher should propose a working hypothesis, which is a tentative assumption made in order to draw out and test its logical or empirical consequences. It's a tentative assumption. It's not that if you tell, okay, this theory will be there, then there is no need to do research, right? So you propose some tentative, which is important, relevant to field, and you can do feasibility in the data collection, right? So there are two who have started already PhD. I will ask them, you did the literature survey, proper literature survey? Zibbo Kantimal and Shuprotim. They are, so you did literature survey and then propose there some hypothesis. So we're working on that. So any problem, you can contact them. So especially chemistry people. I don't know any other employees are there. No. Only two. So they both are very interested in research methodology. They are attending the classes. So this hypothesis will what you will be working on that throughout your period of this PhD period. So this what approach you will follow? How does one go about developing the working hypothesis? The answer is using the following approach. Number one, discussion with colleagues and experts. Right now, you discussed with your colleagues, right? Your guide and your lab mates, So they discussed, and then that helps, right? Because they have a experience. This will not be. This is impossible. You cannot do this. This route is possible, like that. So they can guide you in that way. Examination of data and records. Okay, so this is what the review of similar studies in the area, and exploratory personal investigation, which involves original field or interview. This is somewhat different. So those are the steps which one follow for development of working hypothesis. Then you prepare the design, research design. How we'll go about with the research, right? The research design is nothing but a conceptual structure within which research would be conducted. So initially you have in frame of mind, okay, after this, say suppose every day we'll take some problem. So today I took PT SiO2. So initially what we have to do, we have to synthesize the material, right, of various materials, and then we have to have in mind how I will prove that it is PT SiO2. So first thing, what I think they also do is first they send the sample for analysis by some technique, whether platinum, silicon, or oxygen is there in the sample or not. So that is, as I told you, EDXRF or any other technique you can use to know that, okay, I have, so this is the research methodology or research design specific out of the methodology. I have to send the sample first in composition analysis. Then I'll do a structure analysis. What is the structure of the PT and what is the structure of that SiO2? We'll do an XRD. What is the surface oxidation state? PT is in 0 state, oxidation state, or PT is in +2 oxidation state. We can do an X-ray photoelectron spectroscopy like that. So these are the techniques, research methods you will follow. So that design you have to have a prior idea, so that one by one you can send it for analysis or data collection, and then whatever property you are interested in, that you will definitely measure. So that design should be in your mind. That design should be ready by the time you enter the lab, that design, okay, these are the materials I will follow, and these are this research design, the methods which will follow, the means of obtaining the information, the availability and skills of the researcher and his staff, explanation of the way in which selected means of obtaining information will be, the time available for research, and the cost factor, right? These are the 5 things you have to keep in mind while doing a research design, proper research design. So we cannot think of a research method which the technique is not available here in this, isn't it? It's not there. How we can include in my research? I cannot include. I can include those techniques which are available with me, or the skill set available with my lab mates. I can do a research design with that skill set. I can develop a skill, definitely. That challenge you can take. And this is how you will do a research design. So we'll do a lot of study in research design in 2 classes, all general, for everybody. and determining the sample design, as I told you. So all the items under consideration, any field of inquiry constitute a universe or population. So in research methodology, this is a sample, the whole thing, it's known as universe or population. A complete enumeration of all the items in the population, known as census inquiry. It can be presumed that in such an, when all the items are covered, no element of chance is. But a slight element of bias in such an inquiry get larger and larger as the number of observation increases. So in error, what they are talking about, a slight element of bias in this sampling, this will go on increasing. Besides, this type of inquiry involves a great deal of time, money, and energy. It's sample basis. Hence, quite often we have 2 items from the universe for our study purposes. As I told you, you cannot select all platinum concentration. Okay, we'll select only few. The items are selected constitute what is technically called a sample. Those are known as the sample. Others are not the sample, right? The sample design is decided by the researcher, taking into consideration nature of the inquiry and other related factors. So this is what the sample, which you will define at the initial stage only, that is very crucial, because from that 3 samples or 5 samples you study, you cannot take the whole universe as the sample, right? All concentration of PT in SiO2. So all those 5 samples which you will study, those 5 samples, whatever correlation or whatever it's known as property correlation, or composition structure correlation, structure property correlation, whatever property you are studying. Somebody is studying the optical property, somebody electrical property, somebody catalytic property, somebody magnetic property in physics, I think. So all those composition, whatever the property you are studying, that correlation, you are studying for 5 sample, but think you have to do it in such a way that it can be extended to the whole universe, right? So that generalization, so that is why sampling is very important, which samples I will take, so that it can be extended for the whole universe. So I will definitely take 0.1, 0.2, 0.3, or 1, 2, 3. I will try to take 1, 5, 10, like that, what I'm telling, so that it can be extended to the broader range of samples. So this is what sampling design is. And then collection of data. Okay, so then comes data collection. So data collection, what we'll do in dealing with real life problems, is often found that data at hand are inadequate, and hence it becomes necessary to collect the data that are appropriate. There are several ways of collecting the appropriate data, which differ considerably in the context of cost, time, and other resources at the disposal of the researcher. Primary data can be collected either through experiments or through survey. Survey means, because this is a broad the research methodology, right? Some people are doing research through surveys also, marketing and all those things which we are doing, business research. There are several methods of collecting primary data, particularly in surveys and descriptive research. Important ones are observation, interview, questionnaires, schedules. All these we'll study in details. These are in the syllabus. So all these we have to do. And then execution of the project, how we will go about it in the project. If execution of the project proceeds on correct lines, the data to be collected would be adequate and dependable. The researchers should see that the project is executed in a systematic manner and in time. If the survey is to be conducted by means of structured questionnaires, data can be readily machine processed. So nothing but collection of the data in time bound manner. This is what has to be done. So through interviews and whatever schedules, whatever is there in the research methodology, then you have to do. And then finally, you have to sit and analyze the data. That is more important than data collection. You have to do anyways, you will do. But analysis is where the trick is. Okay. So a lot of stress is given, that is why, on analysis. A proper analysis and correlation will help you in this improving, or whatever, what I will say, improving your quality of the research. So what is, after data has been collected, the research can turn back to the task of analyzing them. What it involves? It involves establishment of categories, the application of these categories to raw data through coding, tabulation, and drawing statistical inferences. So what in general the science people will do, these are general tabulations are done for other all types of research. So here we collect the data and make graphs, right? you use some softwares to graphically represent your data. So with some property, something is increasing. With some property, something is decreasing. So as I told you, for the example of platinum, PtSiO2, platinum silica particles. So the temperature we will do, suppose read what I will do, thermal treatment, as I told you last day. So how the platinum particles are uh, changing with the thermal treatment or with the method of synthesis, how they are changing. So we plot generally for better, we have to analyze the data and also represent it, tabulate it. So the way you can tabulate it or you can graphically represent it. So graphical representation becomes simpler or better. So graphically we can do a better representation. So in x-axis, if you plot the particles size, sizes of the particles, 1 nanometer, 2 nanometer, 10, 20, and the temperature of the treatment, 200, 500, 6, 800. So you can plot, okay, at what temperature we get the particular particle size. Then you do the activity, catalytic activity. You do a reaction. Suppose you are splitting water to hydrogen. So you are splitting water to hydrogen, and you are getting the hydrogen yield. How much hydrogen we are getting? So that hydrogen, amount of hydrogen, you give the same feed to all the 3 or 5 samples you have prepared and get the amount of hydrogen in each case. You plot it. So with this platinum particle size, this is the amount of hydrogen. So what you do is a property, that is the catalytic activity of that samples, you are correlating with the size of the particles, right? So this is known as activity property correlation. So some property of the particles you are correlating with the activity. Like that you establish a theory. So at the end of each paper or at the end of your thesis, you propose such theories, and you have to see whatever sample you have chosen can be extended to other. So if I take one 10 nanometer particle, it should be true for, you have taken 1, 3, 5, 8 and 10, it should be true for 2, 7, all those all will be falling under the same graph. So graphical representation is better. So during analysis of data, this presentation should be done with the help of editing and tabulation, and we as scientific people, we use graphs to represent it so that it is easier for the audience. You will present, you will publish a paper, so somebody will read it and they should be able to understand after a look, okay, this is what uh, how it is made. So who have signed here in the back? New joinees in life sciences. Those life sciences, many are there, 40, more than 40. 35. What's it? Somebody has not, some people have not joined, left. Oh, okay. Ah, okay, okay. So they okay. आईजी कार्ड से आया, मतलब आईजी कार्ड में लाइफ साइंस में पीएचडी करेंगे वो लोग, हाँ? अच्छा, योर सीनियर्स, बट दे आर डूइंग ऑनलाइन क्लास, नो? Some people, no. So this is how analysis of data you will make, and then you, after analysis, you propose the hypothesis कि with increasing temperature my particle size will increase. Say 10% increase at every temperature increase, and you see at the end of the your data collection analysis, yes, it is falling. So that is what is, you get an intellectual. I yesterday told now why, what is the motivation of research. So you will feel, well, I have done something interesting I've done, and that will motivate you to do something more. Is what palladium लेके देखते क्या होता है, हाँ? So we'll take this time palladium and see what happens, We'll take ruthenium and see if it follows the same trend or not. What do you think? You will get the same trend? Huh? With thermal, it is simpler, but things become complicated if with the temperature. Instead of thermal, you do some other properties, right? And the activity also with particle size, it will expected to decrease. Smaller the particle size, the better the activity, right? You are from chemistry. But you answered not all chemistry. You are from what? Bioscience. Uh, with smaller the particle size, better the activity. So in catalysis, a term has come right now. See, I have to go deviate from this also, otherwise it will not become interesting. So a term has come known as single atom catalysis. I think they are knowing, huh? Dibbu and Supratim, huh? You have heard, na? Yeah, so that is a very updated, uh, one of the advanced fields where only in the silica, on the support silica, if you can disperse only one atom of platinum, huh, throughout. So there should not be two atoms, only one atoms of platinum dispersed throughout. Huh? The single atom catalysis they are called. So it will be highly active. Maximum atom utilization means platinum is costly, right? If you do a single atom dispersion instead of 1,000 atoms, this single atom will be able to give you the same activity at much lower platinum content. So it is known as atom economy. So with economic improvement you can do by help of single atom catalysis, but they are facing a threat also. What is the threat? That these tends to adhere together. So the clusters, so from atoms what you go to clusters, and from clusters to bulk, huh? Like that the size increases. The bulk aggregation property will be much less than that of single atom, right? And the clusters will be intermediate depending upon sizes. So that is the threat. So can you solve this? So during your PhD, somebody, whether you can solve, we will prepare a single atom catalyst that is not agglomerative. By what strategy? Simple strategy I told you. You prepare a support such that the support is able to hold it tightly. So just I told you one problem. As so many problems are there in catalysis itself, uh, fundamental problems. But it can be applied for any type of industrial reactions or relevant reaction, chemical reactions. And then you test the hypothesis. So whatever you proposed initially, okay, I will do a particle size versus temperature and that particle size versus activity correlation. I will do this hypothesis proposed, and you told that okay, with increasing particle size it is expected that it will the activity will decrease. So you'll go to very low particle size, go to single atom and have the highest activity, with minimum platinum incorporation, and you achieve it. So you do a hypothesis testing at the end of your work or the thesis. So this is what, again, those are can be according to whatever you have proposed, or they can happen to be contrary. You can get just the opposite. Then you have to sit and think, okay, why are we getting the opposite? So this is what is hypothesis testing is about. And generalization, as I told you, you have taken 5 samples, right? But it should be applicable to the universe, the whole population. The platinum catalyst industry is this catalysis industry in chemical industry, in chemical around 80% of process use some catalyst or the other in homogeneous heterogeneous media. So this is a very big industry in catalysis. If whatever generalization you propose and interpret, that will be useful to those industries, right? At the end, it may be possible for the researcher to arrive at a generalization. Then you propose a generalization. That is a theory. At the end of the thesis, you propose a theory. See, this is what I have studied like this, and I've seen that with if you can propose a qualitative theory with particle size is inversely proportional to activity and inversely proportional to temperature, like that. And if you can define the constant, then there is no excellent. It will be you equate it quantitative, you get quantitative expression. These are all I'm telling how you arrive at some generalized theory at the end of your thesis. So whatever work you are working on, whatever problem you are proposing, then you do the proper literature survey, do a hypothesis proposal, you propose a hypothesis, and then you do a research design and लगे पड़ो फिर काम करते रहे, डाटा कलेक्ट किया, एनालिसिस किया प्रॉपर विथ लिटरेचर सर्वे कंटिन्यूअस. इट्स नॉट दैट इट्स सेपरेट, दैट डाटा researcher lies in his ability to generalizations. Okay, so try to generalize something, or even if you do not able to come up with a generalization, give a product. Say a vaccine is given or a catalyst is given, like that. So I will tell you the story which I did my thesis. So I did work in my thesis with iron oxide catalyst, and there was one reaction known as sulfuric acid decomposition. My HBNI ka list hai thesis. First page my thesis is there. You can go and see. So I was from the first batch. When HBNI opened, so I did. I registered in 2007 and submitted. I think in 2012 I got the degree. So so during that thesis, I did work on iron oxide. Okay, you must your boss is doing so iron oxide, and we did various iron-based catalysts. We did a lot of surveys with many catalysts we did, and I investigated this specific one reaction, that is sulfuric acid decomposition. Other part also some basic research we did in photocatalysts, but I am talking about sulfuric acid. So proposed at the end of the theory, I proposed that okay, chromium doping, 10% chromium doping in iron oxide, that gives enormous yield, increase in activity of sulfuric acid, decomposition of sulfuric acid to give SO2. You will not understand if I tell oral. I just tell him. Okay, and then proposed that okay, these are highly stable. These are not agglomerating. This density, the sintering effect is minimized with the help of chromium. This is what I proposed during thesis. Then those sample was taken up in 2013 in an engineering scale. One plant came up, iodine sulfur cycle plant, and chemical technology firm. There, these catalysts were used. And then at the engineering scale, there was some problem of mass transfer. The engineers, they know what is the mass transfer issue in catalyst. I don't. So in that scale, there was some mass transfer issues. So with the same composition, we changed the form of the catalyst. Such a porous form we prepared, and then in 2022, this catalyst was employed in a bigger plant, in BRC. And right now, the plant is coming up in heavy water board. Okay, that is in Chembur, and there these same catalysts will be used in 3 meter cube of hydrogen generation, a very big plant. Okay, so this is how thesis, whatever you do a small research in a small thesis, it can evolve in a bigger way. You will see later on in life. So this gives a lot of satisfaction. Whatever I have done during a PhD, it is being used in 2 plants, and it is proposed to be used in a very big plant in future. And if that process comes up, then nothing like that. So this is how generalization and whatever you interpret, and that 2025 this year, this trigger of new questions. See, you can whatever you are doing at there is chromium doping 10%, it is decreasing sintering, but we have to understand why it is decreasing sintering. Still, with other problems I am doing, but still that keeps on keeping in mind. Still, we are going on research on that, so it triggers new problems. What is the change in the structure, local structure of chromium doping? So this year also we published one paper. If you see, so this goes on. So it's an unending process. So research is not that thesis ho gaya to end ho gaya. No, it will go on. And at the end of your thesis, you give a product, or give a generalization, give a theory, or at least give some new question to the society. तुमको ये मिला, you cannot solve the whole problem. Why it is happening, I'm not able to solve it. There is somebody, next batch who is coming, they will take up your problem. This problem is interesting, what she did, and there is a question coming up which is not answerable. I will answer that. So this is what makes your problem light. And then preparation of report or the thesis. So this is very difficult. You need months of time to sit down, and whatever you have done throughout the years, you have to sit and write the thesis. So, and at the end of the report, whatever. So there is a in HBNA also I will bring one day. In HBNA there is a pro forma format of the thesis. So introduction, experimental, all those formats are there. So you have to follow that format and prepare the thesis. So these are the criteria for good research. What is the time? 3:30. So I have already overshot the time. So 3:25. We'll start from here, from criteria of good research from next day. And then this is the assignment. It's already there. The red ones are the important. The black ones are only if somebody is interested to go ahead. So you just read the red ones. Black ones are not so much important. But if you want, you can go do. So this is what. So thank you for your cooperation and listening. And we'll continue from next classes on publication, research ethics and publication. Okay. So this is whatever stages we have learned today, we'll discuss in details from the next class. Okay. And if you share me the email IDs, I will share you with the presentation. Huh? All the best. Huh? I was given in the presentation na first day likha nahi? Huh? Huh.